ever pondered if the Earth is truly round? Let's delve into an alternative view, the flat Earth theory. This belief system asserts that our planet isn't a globe, but rather resembles a flat surface, much like a disk. This theory is not a new concept. It has historical roots dating back to ancient civilizations. However, it has seen a resurgence in modern times, thanks to the internet and social media. Flat earthers, as proponents are often called, put forth a range of arguments to support their claims. One such argument is visual perception. They insist that the Earth appears flat, especially at sea level. Another argument is the perspective illusion. They suggest that objects seen at a distance appear as a straight line on the ground. Lastly, there's misunderstanding contrary claims. Some individuals may reject or not understand the scientific evidence supporting the round Earth model due to misconceptions or lack of knowledge. But how does science respond to these claims? Let's take a closer look at the horizon, shall we? Flat Earth proponents often point to the seeming flatness of the horizon as proof of their theory. But this perspective is a bit short-sighted. You see, the Earth's curvature isn't always obvious from our vantage point on the ground. Imagine standing on a beach, gazing out at the sea. The horizon appears flat, right? That's because you're seeing only a small portion of the Earth's surface. However, as you ascend to greater heights, say in a plain or atop a mountain, the horizon starts to curve. Why is that? It's due to the Earth's large-scale curvature. Our planet is immense, and its curve is subtle but very much there. Think of it like standing on a basketball. From your tiny perspective, the surface seems flat, but from a distance, it's clearly round. So the horizon isn't as flat as it appears after all. Objects at a distance, straight line or not? Let's delve into this. The perspective illusion argument posits that objects seen from afar appear as a straight line on the ground, a claim often made by flat earthers. But hold on, this doesn't take into account the intricate play of perspective effects and atmospheric distortions. Here's the thing. When you look at a distant object, it's not just the object you're seeing. You're also peering through layers of atmosphere, each bending and refracting the light in unique ways. This bending of light, known as atmospheric refraction, can cause objects to seem like they're in a straight line on the ground. Now, let's consider some real-world examples. Ever seen a ship disappear hull first on the horizon? That's the round Earth obscuring your view. And lunar eclipses? They show a rounded shadow of the Earth on the moon. Looks like things aren't always as they seem. Science is often misunderstood, isn't it? A significant part of the flat Earth theory hinges on this misunderstanding or refusal to accept the scientific evidence supporting the round Earth model. This could be due to a lack of knowledge or misconceptions. The round Earth model, however, is based on a plethora of scientific observations and principles, including geodetic measurements, gravity, and space missions, to name a few. Understanding these concepts and the science behind them is crucial to debunking the flat Earth theory. It's not just about arguing against flat earthers, it's about educating them, and ourselves, on the fundamental principles of science. It's about understanding that science is not a matter of belief, but a method of inquiry based on evidence and observation. This is why scientific education is so important. It equips us with the tools to discern fact from fiction, to question, to investigate, and ultimately to understand the world around us. With knowledge comes clarity. So, what does science tell us about the shape of our Earth? Well, the steadfast position of science is clear. Our Earth is round. This conclusion is not made lightly, but is backed by a vast body of irrefutable evidence. Space missions, for instance, have provided us with striking images of Earth from above, showcasing its spherical form. Astronauts aboard the International Space Station and the Apollo moon missions have all consistently reported seeing a round Earth. Then we have geodetic measurements. These are precise calculations of the Earth's shape and size, and they too affirm the round Earth model. Finally, let's consider gravity, an invisible force pulling everything towards the center. It's this force that shapes planets into spheres. Gravity pulls from all directions, making the round shape the only one that every point on the surface is equidistant from the center. The Earth, it seems, is indeed round.